Rahim. Now we're going to continue our revision of dynamics, rectilinear motion. Okay, this session is dedicated to explain in details the curves relating to the rectilinear motion of any body. Okay, as we said during explanation, we have many vector function relating to this motion. We have s or vector or x vector. This is displacement, okay, displacement vector. Also we have velocity vector. We have acceleration vector. Okay, all these vectors we can relate each of them with time, okay, t, by using the suitable or proper curve representing the relation between any of these vectors with time. Okay, we'll start explaining the relation between the displacement or the position, okay, with respect to time. Okay, then we'll explain position or displacement time curve. If we have this curve, okay, showing the relation between the displacement or position of any body moving in rectilinear motion, okay, with time t, okay, and we have this curve, for example, in this form. Okay, from this curve we can find out the velocity, okay, as the velocity equals dx or ds, here s or x, ds dt. Okay, then at any time, for example t1, if we find the slope of the tangent to this curve, okay, st curve, okay, this represents the velocity of the curve of the body, the velocity of the body at this time t1 or within time interval t1 and t2. Okay, as we said also, the slope of the tangent of this curve can be represented by the angle made by this tangent with the horizontal axis, time axis or x-axis. Okay, for example, if we have here, for example, this time t2, and we make here an tangent to this curve at this point, and we have here theta. If theta is acute angle, okay, then the tangent slope of the tangent is positive, okay, and consequently velocity is positive as well. Okay, and vice versa, if we have here this tangent, okay, and we have here theta, for example theta 2 at this point, then at this point, okay, theta is obtuse angle, then velocity, then the slope of the tangent at this point is negative, then velocity is negative as well. So it's too important to know that if the velocity of the body is positive, then the body is moving in forward direction. Okay, if the velocity is negative, v is negative, then the body or the motion of this body is in backward direction. Okay, this is depending on the sign of the velocity. If the velocity is positive, then motion is forward. If the velocity is negative, then the motion is in backward direction. Okay, first step is how to find out the velocity from ST curve. Okay, and as we said, if v is positive, then the motion is in forward direction. Is if the velocity is negative, then the body is moving in backward direction. Also from this curve, ST curve, okay, we can find out the acceleration acceleration A of the body, okay, of the body, according to the form of or the curve of this motion, representing the relation between displacement or position with time. If we have this curve, for example, okay, at T1 we have T1, T2, T3, okay. During T1 and T2 the curve is upwards convex or convex in upwards direction. Then the acceleration during this time interval T1 and T2 is negative, while during the interval T2 T3 the curve is downwards convex. Then the acceleration during this time interval is positive, okay. So at time interval T1 and T2, okay, acceleration A is negative, okay. From T2 T3 acceleration is positive, okay. Then from this curve also we can find out the sign of the acceleration, if it's positive or negative, as we explained, okay. We'll move to the velocity time, okay, curve. Second curve represents the relation between the velocity and the time of the motion of the body in a straight line, okay. If we have this curve, for example, okay, the relation between velocity and time for the rectilinear motion of any body, and from this curve we can find out the velocity, sign of the velocity, okay. If the velocity is above of the curve representing the velocity with respect to time is above in this area, above the x-axis, okay, which is represented by time, okay, then velocity is positive, okay. Here v is positive and here of course v is negative. If the curve is below x-axis, which represent by time, then velocity is negative, okay. This is the first one. So from this curve we can find out the acceleration of the rectilinear motion of any body, okay. If we have this curve, for example, this relation between the velocity and time, okay, then here for example T1 and here T2, and as we said in this step during T1 T2 velocity is positive as the curve is drawn above the x-axis. From 0 to T1 and T2 T time greater than T2, the curve is below x-axis. Then during this two interval the velocity is negative, okay. To find out the acceleration from this curve, we can say that acceleration can be represented by the slope of the tangent to the curve at any time, okay. The slope of the tangent at any time is representing the acceleration of the motion of this body, okay. For example, during a time interval from 0 to, for example, t, okay, dash, here the slope of the tangent, if we draw any tangent here during this time interval, then the slope of the tangent is positive as the angle made by this tangent with the horizontal axis, x-axis here, theta is acute, then the slope here is positive, and consequently acceleration during this time interval is positive as well, okay. If we draw here a tangent to this curve like this during this time interval, okay, the tangent make an obtuse angle with the horizontal axis, time or x-axis, then during this time, okay, or this interval, the acceleration of the motion of this body is negative, okay. So again, from Vt curve, we can find out the sign of the velocity, positive or negative, according to the position of the curve, representing the relation between velocity and the time. And also we can find out the acceleration of the motion regarding to or depending on the slope of the tangent to the curve at any time. Okay, then we are going to move or explain the last curve representing the relation between acceleration and time. We assume we have the acceleration time curve representing the relation between acceleration and time of the rectilinear motion. If the curve is drawn in this area above x-axis, then the acceleration is positive, and if the curve is drawn below this x-axis, then the acceleration is negative. Okay, for example, if we have this curve, for example, representing the relation between acceleration and time for any rectilinear motion of any body, then from this time to this time, t1, t2, and here for example t3, from t1, t2 the acceleration is positive as the curve is drawn above x-axis. From t2 to T3, the curve is below x-axis and the acceleration is negative. Okay, now we have to discuss a very important point relating to how to define if the rectilinear motion of any body is accelerating or decelerating. Okay, and if it's forward or in backward direction. Okay, here this is depending on the relation between velocity for this item and velocity and acceleration in this item. Okay, for forward and reverse, forward or backward or reverse motion, we have to check sign of velocity, okay, of the motion of this body. If the velocity is positive, then motion is in forward direction. Okay, if the velocity is negative, then the motion is in backward direction or in reverse direction. Okay, for acceleration or deceleration, we have to check the sign of VA, the velocity, and times acceleration of the motion of this body. If this product VA is greater than 0, then the motion is accelerating. Okay, if VA is negative, okay, less than 0 is negative, here is positive, then the motion of this body is decelerating. Okay, now we are going to apply the previous explanation about each of these curves to identify if the motion is accelerating or decelerating and the direction of motion is forward or reverse. Okay, first we are dealing with ST curve, position time curve. For this case number 1, we have this curve representing the relation between S and T. It's required to find during the time interval A and B the type of this motion. Okay, here as we said, we have first to find the velocity during this time interval in interval A and B, the sign of this velocity. Okay, here as we are dealing with ST curve, then to find a sign of velocity, this velocity is represented by the slope of the tangent to the curve at this or within this time interval A and B. As we draw here this tangent, okay, to this curve, then the tangent make an obtuse angle with this horizontal or x-axis theta here. This theta is obtuse, then the slope of the tangent is negative, then velocity during this time interval is negative as well. Okay, then we have here backward motion. Okay, this is first step. Second, we have to find A, acceleration during the time interval also A to B. Okay, as we are dealing with ST curve, then to find the sign of acceleration, we'll check the convexity of this curve. Here we have the convexity is the downwards convexity. Then we have acceleration here is positive during the time interval A and B. okay, then A is positive as we showed here, okay. Then to find the type of the motion, if it's accelerating or decelerating, then we have to multiply V cross A. Here we have negative cross positive. This is equals negative, okay. Then VA is negative less than 0. Then the motion here is decelerating. Motion is decelerating motion in backwards direction. This is this is for this first case. We repeat this investigation for this curve, relating also the relation between displacement and time for the motion of any body. So you have this curve, okay. It's required to find the type of motion during A and B time interval, okay. As we said, during interval A and B, we have to find two variables, velocity and acceleration. Velocity here, as we are dealing with ST curve, then the tangent to the curve, the slope of the tangent to this curve during this interval A and B represents the sign or the velocity of this body, okay. Here if we draw this tangent, okay, the slope of this tangent is positive, as the theta is theta here, the theta made by this tangent with the x-axis is acute, then the slope of this tangent is positive, then velocity is positive as well during time interval A and B, okay. We have to check the sign of acceleration here. Here the curve is upward convex, then A is negative here, then here A is negative, okay. You have to be sure that we are dealing with ST curve, okay. Then the sign of acceleration depends to the type of convexity of this curve within this time interval A and B, okay. Now here we have velocity is positive, then motion is forward, okay. And to find accelerate is it accelerating or decelerating, then we have to multiply V and A. We have positive times negative, then VA is negative, okay. Then the motion is decelerating also, but in forward direction, okay. Now we are going to repeat these steps with this third curve. Here we have during time interval AB, we have velocity here, the slope of the tangent to this curve during this time interval. Here the tangent make an acute angle with this horizontal axis x, then the slope is positive, then velocity is positive as well, then the motion is in forward direction, okay. To find acceleration, here the convexity is downwards, then we have acceleration is positive during time interval A and B here, then VA equals positive value or quantity, then the motion is accelerating in forward direction, okay. For last curve here, we have during this time interval A and B, the tangent of this, the slope of the tangent during A time interval A and B is negative, as theta is obtuse, then velocity is negative, then motion is in backwards direction, okay. Okay, for acceleration here is negative, as the curve is convex in upwards, then acceleration is negative as we explained, okay. To find the type of motion, if it's accelerating or decelerating, then we have to multiply V and A. VA equal positive, then the motion is accelerating but in backwards direction, okay. This is for last curve. Now we are going to explain how to find out the type of the motion of any body, if it's accelerating or decelerating in forward or in reverse direction, regarding to the velocity time curve, okay. For first case, we have a relation between v and t represented by this curve, okay? And we have within this time interval a and b, it's required to find the type of the motion of this body, okay? As we said before, during time interval a and b, okay, we have to find out the sign of v. As we are dealing with vt curve, then if the curve is up above the horizontal axis, then v is positive. Here the curve is above horizontal axis, x-axis, during the time interval a and b, then v is positive during this time interval, okay? Also we need to find out the sign of acceleration of this body within this time interval a and b, okay? As acceleration of this body as the motion of this body represented by the relation between v and t, then if we draw or find out the slope of the tangent to the curve at or within this time interval a and b, we will find the sign of the acceleration of this motion, okay? If we draw here this tangent, okay, the tangent make an obtuse angle with horizontal axis theta during time interval a and b, the acceleration is negative, okay? From this step here velocity is positive, then the motion is forward in forward direction, okay? To find if the motion is accelerating or decelerating, we have to multiply v and a. We have positive times negative, then we have negative value, then here the motion is decelerating in forward direction, okay? For second curve here during this time interval a and b, okay, first also we have to find the sign of v. As the curve is above x-axis, then v is positive, as we are dealing with the vt curve. During time interval also a and b, the slope of this tangent, which representing the acceleration, okay, here the slope of tangent equals 0, okay, then acceleration equals 0, okay? Then we have here va equals 0, okay? Then this means the body is from this step velocity is positive, then the motion is in forward direction, okay? From this step va equals 0, then the acceleration equals 0, then the body moves in forward direction, of course, from this step, but with the constant speed or regular speed or constant speed, as the derivative of this speed, which represented by the which representing the acceleration is 0, then v is constant. Then for this curve during time interval a and b, the body is moving forward in constant speed, okay, or velocity, in constant or regular velocity. For this curve, third curve during time interval a and b, okay, here we have the sign of velocity is positive, as the curve is drawn above x-axis, then v is positive, okay, and consequently the motion is in forward direction, okay? To find if the motion is accelerating or decelerating, we have to find first the sign of acceleration. Acceleration during a and b represented by the slope of the tangent during this time interval. Here the tangent makes an acute angle with x-axis, horizontal axis, then the acceleration on the slope of the tangent and acceleration as well is positive. Then if we multiply v and e, we'll find out here we have v is positive, then motion is accelerating in forward direction, okay, forward direction. For last curve here, we have here during time interval a and b, velocity v equals 0, okay, and consequently a equals 0 as well, and a is the first derivative of v. Then during time interval a and b, there is no motion, the velocity is 0. for this body, then body is stopped during time interval A and B. Another case also representing this curve representing the relation between velocity and time for the motion of any body. During time interval A and B, we have to find the type of this motion. Okay, during A and B, okay, the sign of velocity is negative as the curve is drawn below x-axis. Okay, then motion is in backward direction or reverse direction. Okay, during A and B, time interval A and B, the acceleration of the motion can be represented by the slope of the tangent to this curve during this time interval. Here the angle made by this curve with a positive direction, okay, is acute, as if we, for example, we select this point and we draw this x-axis parallel to this original one. This angle is theta, this angle is acute, then acceleration during time interval A and B is positive. Okay, then to find the time of the motion, if it's accelerating or decelerating motion, then we have to multiply V and A. VA is negative value, then motion is decelerating in backward direction. Okay, for this last curve we have during A and B, velocity V is negative as the curve is below x-axis, and the angle made by the curve, the tangent to the curve during time interval A and B, if we select here, for example, point belongs to this interval and we draw this axis parallel to this original one, then we have this obtuse angle made by this tangent with the horizontal axis. Then here acceleration is negative. Okay, from this step we have backward direction motion, motion. Okay, from this step we have to multiply V and A. Negative times negative, we have positive value, then the motion here is accelerating, okay, from this step, but in backwards direction from the sign of the velocity, and this is required.